Hello dear aspirants, welcome to the Prelims Pinnacle sessions. We're kick-starting these Prelims Pinnacle session with the environment classes. Now again, as we had mentioned earlier, we have very few days left for the prelims examination and you will have to somehow prioritize these topics that you have to study, and you have to also know certain topics in depth, because time and again UPSC tends to ask questions on those levels. So this idea that you have to have for a next 110 days is primarily one of prioritizing certain topics, understanding certain topics in depth, writing tests about those topics, and then going on and revising that areas again and again. Now when I'm saying topics, you have to understand your both static and your current affairs is included in it. So let's just have a brief idea about what environment actually encompasses. Now when it comes to the environment, you all know the UPSC syllabus very clearly gives us, when it comes for the prelims, general issues on environment, ecology, biodiversity and climate change. So one thing I want to clarify to all of you who are here for the session is that, see, when you start studying itself, understand that environment, the subject as it is, be it any theory part you're studying or any current affair, you can broadly divide it into your ecology, biodiversity and climate change. Which means when you have such a broad heading like this, for example, you look at any species that you're studying, any kind of new reintroduction that is there, any protected area that is there, all that will come under the head of biodiversity. Any climate change related activities, which means the different organizations related to it, the different pollutants related to it, all that would come under this specific idea. And then coming under ecology, which is a much more broader perspective where you have the static portions of environment. Now what I want to tell you very specifically is, when you sit to study environment, let's just take a ballpark figure of how many days you're going to give for environment. At this point, I'm pretty sure you all would have a mental number in your minds as to what you would be giving for environment. But ideally, let's take a very ideal scenario as to how many days you have to give. So before I go into this entire analysis, understand that environment as it is can be very easily covered. And if you're studying only environment in that specific day, it can be very easily covered in 5 to 6 days. Now this 5 to 6 days, let me tell you, is for exclusively the static portions of environment. Now when I say 5 to 6 days, assume that on an average you're able to give 4 hours to 5 hours per day. Okay, which means very easily in a span of 24 to 30 hours, based on your comfort of the subject, you will be able to cover most of the static portions of environment and some correlated current affairs also. Okay, so what exactly should be your strategy when it comes to environment? This we will discuss in the beginning a little bit, and then we'll move into the subject. Okay, so I needn't tell you about the importance of environment over here. You know, on an average from 19 to almost 25. So right now the sweet number is between some 15 to 25 questions do get asked from the environment scene. So you have to know that in that very specific perspective. And anyone, I know it's a Pinnacle batch, but then even then there would be a lot of students who have not done maybe a basic coaching of environment or do not have any clear idea about what you have to approach. So for them, let me just tell you, we'll have to look into certain portions. You will have to do at least a basic reading. Now, one common question I get from students at this point is, ma'am, can we read Shankar? Can we read PMF? Now, the point is, see, you can read any material you want, but the point is, what is the return on investment on it? Okay. So, for example, if you are very new to the subject of environment, and you take up a source like maybe that is there in the market like PMF or something, what is likely to happen to you is that the material is made in a way that it assumes that you have an understanding of certain terms. Okay, which means anyone who is not from a science background, who would not have much more clarity on certain terms and all, they will fail to understand what is being mentioned over there, which will again lead you to just mugging up the environment parts. And trust me, when you mug up the environment parts, that is the worst thing you can do to your preparation. Why? Because every static environment question that has been asked in the last few years has been from a deeper analytical understanding. So, if you are mugging up a definition of something which you saw in a material which you've not understood completely, what is likely to happen is, even if they tweak some words here and there, you will be in a very difficult situation. You will not be able to answer it. It is to compensate and to avoid such problems like that, you have to read a basic source which is in a very simple language which you can understand even from the simplest point of view, and that is your NIOS environment PDF material. Even if you just Google NIOS environment PDF, you will get the entire PDF. You can take the printout of it, you can read it from the online source, whatever you want. But trust me, every single concept will be so simplified that you will not have to go and refer Shankar or PMF or anything. Your understanding will be clear. So anybody amongst you who've not done a basic environment coaching, I would suggest you start off with this NIOS. And with the NIOS, you can combine the classes and this would be helpful for you. Got it? So keep that in mind. It's quite important in that perspective. Now, even if you don't have time for anything, you read NIOS. Then, if you do have time, you have a certain NCERT textbooks which is of 11th and 12th. You can have the vegetation related chapters over there. The class 11th chemistry textbook chapter on environmental chemistry. The NCERT's textbook, the biology textbooks, for example, the flora, fauna, the zoology part of it, you can take from that. So, you can just have a basic reading of these aspects. Now, apart from that, whenever you get any doubt, even after these classes get over, and you get any doubt related to any Indian environment measures, ensure that you get into the NVIS site and you take the data from the NVIS site. NVIS is the official environmental ministry site. So get into this and get the data from there. Even on other aspects also, if at all you are in a fix as to you are reading an international environment organizations and you do not know where to place certain environmental organizations, even in that case, always ensure that if you have any doubt in what is the number of members, is India a member, what is the geographical span of it, if you have any basic doubt, ensure that you go to the official websites of those organizations and clarify. Do not take any other source or do not take any other PDF or material as your source for these things. Okay, so I hope for those who have a little bit doubt on what should I be even reading, this part is clear. Now coming into the sources for current affairs. Now this is a quite tricky part. Why? Because see, what normally happens when it comes to current affairs is, for a lot of subjects like for example polity and all, your current affairs is very, very entangled with your static portion. Which means if governor has been in news all the while, you will see governor's question coming up in the mains and in the prelims. Okay. Now environment goes a little bit beyond that. Okay. Now, for example, I'll tell you how beyond that. Now, the thing is that maybe when it comes to environment, 1 year, for example, take this year. This year you had the COP27 summit and the different aspects related to that. Okay, you had all the measures related to the COP27. Now, the probability of a question coming on COP27 is much more less. But what would maybe either come is the entire mechanism of maybe UNFCCC, maybe a previous COP, all of these could be important. Okay, so if other subjects like polity and all take a direct correlation with current affairs, environment, I would say, takes a little bit more deeper correlation. Why? Because it might ask from the base of it. Okay, so keep this in mind when you look into the current affairs. And let me tell you the strategy that I'll tell you for environment and the specific subject of environment is applicable both for your science and tech and certain government schemes related current affairs. Okay, so this you can keep in mind. The idea is now you have just few days left. So you do not have the luxury of going and reading newspapers at this point. So your approach should be in a very clear-cut manner. First, what you do is, if you are comfortable with any particular PDFs or if you are comfortable with the current affair handouts being given out by IAS Baba, whatever it is, choose a PDF or a current affair compilation of your wish. Now, when I am saying a current affair compilation, I don't mean the ones that come out in February saying environment important topics or science and tech important topics. This is not what I'm intending. What I'm intending is that every month, there are monthly compilations given out by almost all the institutions. So, take up a monthly compilation. Okay, and what months will you cover? Now, for example, if you're giving the exam on May 28th, ideal scenario would be you can take from at least your March 2022 to your March 2023. Okay, these many months. Okay, these many months, and if you have the urge, you can obviously go and start from Jan itself. That is up to you. But then ideally at least March 2022 to March 2023, that is 12 months PDF should be taken up. What you do is take the environment portions of it. Do a very preliminary reading. So, for example, any PDF that you take, if it's a very popular and a very comprehensive one, if you take up any of these PDF, if you take the environment part of it, more or less there should be, and this is one criteria you can check if that PDF is good or not. There should be at least on an average 15 to 20 topics under it, just in the environment section. It shows if you are having 15 to 20 topics, you can assume that more than 20, very well, but then you can assume that this is a much more comprehensive material than the rest which is there. So if it is showing abysmally low number of environment topics, understand that it is not a very well researched PDF or anything. So you can eliminate that. You can take up any PDF which has on an average these many number of topics, and this is the same principle you should be following for SNT also. How many topics have been listed? You just go through the contents, based on that you choose a PDF. Then what you have to do is, you have to read monthly PDFs of environment from March to this March. Okay, when you read it, it's up to you. Some people have the habit of just underlining it in the PDF and going away. Now, always my point is that when you do this process where you just underline and go, it's going to be quite tedious to revise it, because trust me, whatever we are doing at this point, you have to revise at least 4 to 5 times. So how will you keep on taking up this PDF, and at times you will remember why you highlighted something, times you will not remember why you highlighted certain things. Now the point is, most of the times also, your PDF, you read the PDF in a comprehensive manner, and Thereafter, if you do have, for example, if it's one of those, for example, a topic like wetland, which is quite important, okay, they've given some information in the PDF, but then you as an aspirant, knowing that wetland is a little bit more important, what you should be doing. So as I was mentioning to you, when it comes to the different PDF compilations, we have to now understand that you have to take the time period from these specific times and thereafter you have to read the PDF compilations pertaining to environment from all of these areas. Okay, now one more thing you have to understand over here is, in this entire program, you also have your current affair tests. So how do you go about a topic? This is something that you have to understand, because a lot of times students read the current affair PDF. They do not fault on over there. I'm pretty sure you all are very serious aspirants who would have already read a set of PDFs. But then when you write your tests and you see a current affair question, most of the time what happens is, if it's a 3-statement question, you will know one statement, you will not know anything about the other 2 statements. You will have to use some elimination technique and solve it. Sometimes it works, sometimes it doesn't. There are instances where absolutely all the 3 statements or the entire topic itself asked is out of your bound and out of your reach. You have not seen the topic anywhere. So in all of these cases is where you have to understand your current affair preparation of environment needs to be much more larger and comprehensive than the static preparation. Static preparation will be sorted once you sit in this class. Okay, because all the important areas that you have to know, we will be focusing on it. We will be giving extra importance to it. Any current affair related to that also we will be discussing. So static portion is pretty much sorted. But for the current affair, you have to follow an approach whereby which you will read a PDF. You will write several tests, not 1 or 2 current affair tests. If possible, on a daily basis, if you are able to approach current affair questions, well and good. Be exposed to maximum number of current affair topics and current affair questions. So when you get exposed to that, then only you will be like, okay, fine. Because most of the time, the PDF, even despite having 15 to 20 topics, it will not have covered things in a comprehensive manner. Okay, so now here you can understand, in this case, here you can approach this, use this as a strategy when it comes to your current affair preparation. PDF plus test. So as I was telling earlier, when you read the PDF, so for example, if a PDF is to an extent well researched one, most of the important details will be given. Okay, now for example, as I was mentioning in one of the previous classes, there is something called as an India Antarctic Bill at this point. It's not a bill, it has become an Act 2022. This is a current affair. So when you see this is as a current affair from the environment point of view, what all will you deal under it? See, ideally a PDF of yours will mention about the Act. I mean, they have to do that. Okay, they'll mention about the different provisions of the Act. They will mention about what are the activities prohibited under the Act. Okay, the Act is primarily dealing with the Antarctic region, and India, what it is going to take some measures for the Antarctic region. Okay, so the prohibition, the objective of the Act, they might even go about and talk a little bit of, if at all anyone is going against the provisions, what is the penalty for it. So these many things will be covered in a standard PDF. But as an aspirant, don't you think the devil is actually in the details? The question will never be about the provisions of it or what is the amount of punishment given or nothing like that. What might be asked as a question would be as simple as what is the Antarctic region, which we are all assumed to be like, we know it. But then let me ask you, what is the Antarctic region? without even knowing about any of this current affair, if I just ask you, what is Antarctica? Now, some of us will have an idea, maybe it's a continent which is out there. Some of us will be around the pole region. Now, in the certain global, conferences and everything, Antarctica has been described as all the portions which fall under 60 degrees south latitude. Which means if you have any sea over there, if you have any continental shelf over there, if you have any glacier over there, if you have any airspace over there, all this falls under the idea of Antarctica. So Antarctica is not just one single continent which is out there. Got it? So now this has to be understood, because UPSC will pick on that and they can twist and ask a question related to it. Got it? So your learning of that Antarctic Act will be incomplete, because one of those statements, maybe the first statement itself will be Antarctica is the region, all the regions below 60 degrees south. Most of us, when we see all itself, we are like, fine, it's wrong, because absolute statements will not be correct anytime. So then we will put wrong. But the fact is, it is all the regions below the 60 degrees south latitude. Okay, so get this concept clear. Next thing is, it's an India Antarctic Act 2022, which means India has some mission in Antarctica at this point. So we need to know about those missions. Sometimes the PDF will give those missions, sometimes it might not give. So we need to look a little bit extra, which I'm saying is, when you read a PDF and you find India Antarctic Act and you take maybe 3 minutes to read and process that entire thing, all I'm asking is, take one more extra minute, just go check India Antarctica Act in news or Antarctica in news or something like that, and you find some extra information that can be asked as a UPSC question. Now, how will you know what can be asked as a UPSC question? And to that, this thing becomes complete, or this package becomes complete with this part. Previous year questions. Which means, before you go about and start your entire study of environment, the first thing you should be exposed to is the previous year questions of environment. And in the previous year questions, when you're looking itself, you ensure you have a static area and you have the current affair portion. Okay, the static area primarily is the portions where, for example, you have certain terms, certain definitions and everything. So you analyze that and you try to understand, okay, from where a lot of questions have come, what is the layer of questions that has come. When I'm saying layer, how deep the question has gone. Like, for example, are they asking just a simple definition of food chain, or are they asking what all you're able to infer from a food chain? If they're asking the inference of a food chain, it's a much more deeper question than the superficial first layer of just what you say, definition of it. Okay, now in this aspect over here, once you look at the static portion, what will be left is all the current affair question. Observe how they ask current affair questions. If it is an act, what depth do they go into? If it's an organization, what depth do they go into? Based on these things, then is where, when you look into a certain current affair, you can know, okay, I need to look these informations for it. So for example, after you look through this entire current affairs, you will realize that when you study an environmental organization, you have to know if it's an intergovernmental organization or an NGO or an educational initiative. What category it falls into, you will have to know. Got it? So this becomes important. So your preparation of environment, keeping aside the static part, will become complete with this three-pronged thing, which is first your previous year question, then you read the PDF, then you take the test of current affairs. And trust me over here, the same strategy is what works for your science and tech also. Okay, so it might not be the case if another subject like economy or for polity, it might be a totally different strategy. That is not what I'm saying. For environment and science and tech, this is the strategy you have to follow. Okay, so keeping this in mind, what I have also planned, because this is a pinnacle session and you guys are at the cusp of writing the exam, what we'll be doing is, over the course of our next 9 classes, I will be taking up question papers of the past 9 years. Okay, not the entire question papers, the environment portion of it. So I hope to cover somewhere between your 2022 to your from 2013 to 2022. So these many years of question papers, every session towards the end or in between also, we'll be discussing whenever we need, you guys have heard the class and you're feeling a little bit tired. At that point, we'll be discussing these set of questions. Okay. In this way, we can ensure that you at least have a 9-year advantage when it comes to looking at the previous year questions. Okay, so now with that in mind, let's also go into, now this is something that I was telling, despite doing all this also, sometimes you might feel a little bit confused, and that is because a lot of contemporary terms related to environment do come. But don't worry, those terms will be covered in the sessions that are going to follow, so you don't have to worry about that. Now, just to kickstart the session which is there, look at this question, which is your common carbon metric. This is a very common term which is there. Like, this was asked in last year, and they've said it is supported by UNEP and has been developed for 4 options are given over there. Okay, I want you to just analyze for yourself and tell me what the answer is. Here you will see, assessing the carbon footprint of building operations around the world, enabling commercial farming entities around the world to enter carbon emission trading, enabling governments to assess the overall carbon footprint caused by their countries, assessing the overall carbon footprint caused by the use of fossil fuels by the world in a unit time. I'm just giving you a little bit of hint on to how these sessions would be. So we will have a lot of questions that are placed in these sessions so that you are constantly on your foot thinking of these answers. Now tell me how will you reach an answer to this? This is a previous year question, and the reason I put this question specifically is because, as I told you, a lot of contemporary terms tends to be asked. Now when I'm saying contemporary terms, it primarily means those terms which have been in use for the past 2 to 4 years. Now come on, we all are not veterans in UPSC preparation. Veterans in UPSC preparation so much so that we'll know all the terms that have been in the news in the last 4 to 5 years or something. So how do you compensate, or how do you understand these terms? A lot of these terms will be discussed in class, so don't worry about that. But if at all a term does come and you are not able to get the answer, you have to understand, looking at these things, how will you get to the answer? See, I'm hoping all of you have a mental answer in mind. Any one of you who've chosen A option, you can think for yourself. Anyone who's chosen B, C or D options, you should have a clear logic in mind as to what you've chosen. So I'll try solving this question. Okay. Now the term is common carbon metric, which means it is some kind of a global, something that is very common to everyone, something that is acceptable by someone. Common means what? Common is something that you see everywhere. It's something, when we say common things, it's not something that is rare, it's something that is accepted by a lot of people. So looking at these things, assessing the carbon footprint of a building operations around the world. If we are not very clear of it, leave it there. Enabling commercial farming entities around the world to enter carbon emission trading. See, look at this. This is something that has been brought about by UNEP. Okay, what is UNEP? UNEP is the environmental arm of United Nations. That's the United Nations Environmental Program, right? Don't you think the United Nations Environmental Program will have a wide group of countries in it? Not just developed or developing, it will have large group of countries in it. When they bring out something and they are calling it the common carbon metric, do you think they will be focusing just on something called as commercial farming entities? Think about it. Who are these countries who will have a lot of commercial farming? These are the developed countries. See, the developed countries are in a much better position right now. They do not need extra assistance coming in from UNEP in any form. Okay, if anybody needs any kind of assistance, it's the developing countries. That is the first thing. Second thing is, when you are assuming and something is given out in a very common way, do you think it will be related, or it will be a concept related to just few countries out there in the world who are practicing commercial farming? No. In that case, it doesn't have to be a common carbon metric or anything, right? So here, by those two logics, I am eliminating this. The probability that UNEP will bring about something related to commercial farming is very, very bleak. That is why I am eliminating B. Then moving on to C, enabling governments to assess the overall carbon footprint caused by their countries. Again, see, ideally, this is something that UNEP can bring. Why? Because all the countries are there together. UNEP will give a criteria. You all tell us how much carbon footprint you are causing. Now, do you think UNEP can do this? So, I have already established that. But do you think the countries will be very welcoming of this? Countries will be like, see, our carbon we will manage. You don't bother us about. Because why? Every other funding mechanism right now in the world, every other power position which is there in the environmental scheme, it all comes from countries saying that, see, we are reducing our carbon footprint. They are not reducing it. They are the ones who are causing too much. There's a lot of politics going on over here. So, do you think any country will take that initiative? Okay, fine, let's all come together and let's put a common carbon metric so that we can put it in a very transparent manner, all our carbon footprint? No. So, because of that logic, you can eliminate that second or the third option also. Finally, coming to it, assessing the overall carbon footprint caused by the use of fossil fuels by the world in a unit time. Now, here I go back to this first term that I read, common carbon metric. Okay. Now, in this case, metric is something. When do you use the word metric? It can be something to measure, but then metric is directly derived from something called as your meter. Okay. Which means it is in some area thing that we are measuring. Okay. It is some kind of a, some kind of a provision which is there, some kind of a square feet or some kind of an area unit is what I'm understanding. Here in the last option, they're saying in unit time. That does not go with my logic of common carbon metric. So, I'm eliminating this. Finally, leading us to that first statement, which is assessing the carbon footprint of building operations around the world. Building operations is primarily just your constructions which are there. Anytime any construction is being caused, to understand how much is the carbon that comes from it, you can use this logic. So, by that, you can take your common carbon metric. Okay, so that sorts that. Now, just as an assignment, because you all are, in this mode, and I hope you all are preparing your current affairs also, what I would like to see you all do is take up these different topics which I have put over here. These topics have featured in the news in the last 2 to 3 weeks. Okay, so there is something called as an Escazú agreement. There is something called as Mishti, Amrit Dharohar, and Green Credit Mechanism. So what I want you to do is, if you do have a PDF or anything good, you can go and do this entire mechanism whereby you read the PDF and you get the points. But I want you to make short notes of it, and if possible, reach out to me so that I can help you, like, okay, is this the manner that you should be doing it if you're missing out any important points. Okay, so this can be done. I hope you all try this. This is like a first task, and my classes will be with a lot of tasks here and there. So I want you to do these tasks so that, again, the first place, because this is an online class, I want you to be very active over here. Okay, so try making short notes on these topics in the point of view of UPSC exam. I don't want to know the entire history of the Mishti or Amrit Dharohar or any anything. I just want to know from a UPSC perspective what can be a question from this area and how what all information you've collected related to it. Okay, so moving on, let's also finally conclude this area by telling, see, when it comes to your general criteria of making your notes, when it comes to environment, you have to understand one very clear thing. See, when you give out certain, information, when you write down a lot of information from your PDF into certain notebooks, students more or less make the mistake of dumping all the information together. Now the thing is, our brain can actually learn this information better if it is actually given in a separate, clear-cut, okay, like for example, organizations, environmental organizations are there. When you write down your notes itself, ensure that all the environmental organizations are put together. Got it? Then take your agreements which are there. At that point, ensure all the agreements are put together. Okay, in this manner, when you make the notes itself, try to see that, okay, your species, your protected areas, the different laws related to India, all are subdivided in this manner, and you write the current affair notes in this manner, which means it will be easier for you to revise. Okay, it will be easier for you to revise, it will be easier for you to even add any extra information that you are getting into these notes. So just a clue over here, I know a lot of students might not want to follow this, they might want to do a diffused writing. This is something that I have taken from my experience of learning environment, that it becomes much more easier when you have these subdivisions, it becomes easier to study it. Okay, so try making your notes in this manner. It will be a little bit more appealing to your, sensibilities. Now with this, let's start the first part of the class where we will be going through certain basic terms of environment which you have to have a crystal clear understanding on. The reason why I'll be going into detail of these terms is because, see, if you do not know the actuality of these terms, what is going to happen is they will mix match these terms and you will be in a very big fix. So let's get started on this. Okay, now coming into the first term that we have to look into is the term that is our subject itself, which is environment. What exactly is your idea of environment? Okay, now understand that when I say environment, the first thing that has to come to your mind is your different surroundings around you. Okay. Now, if there is some kind of a creature, there is some surroundings around it. This happens to be, in normal parlance, the environment of that organism. So, you will see, if you take any creature, it can be a living thing, it can be a non-living, it will have an environment around it. If you take a table, the table will have an environment around it. Right. So now to understand that, see, when we speak environment in actual terms, in scientific terms, you have to understand, it is that area. So for example, if I am standing here, what all is around me? There is a space. I'm standing on a podium sort of a thing. So there is a space over here. There is the air I am breathing. There is the light that is enabling you to see me. There is the fact that I am having an entire body system and everything. So what is basically the environment around me? The environment around me is all these different factors which are there. So what I normally call as surroundings has biotic, abiotic, all these factors around it. When I'm saying biotic factors, it's basically living factors. For example, if you have any microorganisms around me, these will all be the biotic things. Abiotic is the light and the temperature and everything. So all this is what makes my environment. So to put it into very, very plain terms which are there, environment is the natural component in which your biotic and abiotic factors interact among themselves and with each other. Okay, so if I am here, you have all these interactions happening around me. This composes my environment. Similarly, you take anything, you take a table, you take a chair, whatever it is, if there's an environment around it, with us seeing it, with us not seeing it, you will have all these factors, and these are what comprises it. So to just put it, an environment will have maybe animals, it will have air, water, plants, soil, humans, minerals, it might have microorganisms. All of these things is what is composed in an environment. Ideally, if you look at it, you will have certain nutrients, water, air, which falls under the physical components. You will have certain biological components, which is biomolecules and organisms. You will have certain chemical compositions, which is your carbon cycle, nitrogen cycle, etc. So these are all the things that are composed in these regions. Now coming on to what exactly is another term. See, if you understood environment at this point, then comes the next term that is commonly misunderstood, I would say. So, biosphere. See, when I say biosphere, because we all have this thing of, oh yeah, biology, biotic, anything that has life, we will assume it to be given the term bio, right? So, similarly, let's go by that very simple logic itself. Biosphere. Any area on earth which has life, you can call it biosphere. Simple terms. Okay, so if you take up any of these things, you have your lithosphere, you have your atmosphere, you have your hydrosphere, any of these parts in anything, for example, on the lithosphere, when there is life, that you can call it as part of the biosphere. In the water, when there is life, you can call it as part of the biosphere, which basically means it is the biological component of the earth, which includes lithosphere, hydrosphere and atmosphere. Okay, all of these things are included when it comes to the concept of biosphere. Now let me ask you one more thing over here. When I'm saying biosphere, you also have to get the idea that, see, okay, so when I'm saying biosphere over here, what you can basically see over here is that you have the living matter, and at times what, for example, this is a keyword or a catch point over here. Living matter we all understand. Okay, that's something that has life. So when I say biosphere is something that has life, that does not assume that, okay, anything which is dead is not part of the biosphere. If you have something which is a dead organic matter, that also forms part of the biosphere. In that case, don't you think the definition of biosphere should be a little bit more deeper, rather than just saying anything which has life is biosphere? So then we go on to assume that anything which has an organic component can be brought under the definition of biosphere. Okay, and when that happens, life is basically the chief characteristic feature over there. Okay, so life, when I am saying, even in the dead organic matter, when I am saying life, what it is there? You have the carbon compounds which can lead to life. So because of both of these logics, you can understand that you have biosphere all around the earth. Now my question is there any place on earth where there is no biosphere? And one more question, here I said the dead organic matter. Now in this scenario, instead of dead organic matter, if I just told you inorganic matter, my question is, would that fall under biosphere? No, it will not fall. Why? Because inorganic matter does not have a specific carbon compound. If it does not have a specific carbon compound, it will not be characterized as something that is forming life. Got it? So, if it was inorganic matter, it would not fall under the ambit of biosphere. Now, coming into my next question, which is there, do you have biosphere all around the earth, or will you be able to find biosphere everywhere in the earth? Think about it. Now, on the whole, we look at it, we are like, yeah, everywhere there is life. But there are extreme points on the earth where life is not possible. So when I'm saying extreme points, understand, if you take the poles of the earth, and on the poles of the earth, if you go to almost 8,000 meters above the sea level, which is there, 8,000 meters above the sea level, which is there, you will not find any kind of life over there. Okay, so 8,000 not meters, 8,000 kilometers above the sea level, you will not find any kind of life over there. So those regions you cannot technically classify under the category of biosphere. Similarly, if you take up any, extremely high temperature, maybe a volcanic zone which is there, or the volcanic, the lava that is coming out from there, there also it is practically impossible to either find living matter or even dead organic matter, because any of these things which are over there would perish off. Which means even on those areas where there are extreme points on the earth, you will not have life or organic matter, thereby causing the idea that you will not technically be classifying it as biosphere. The reason I've gone into such depths of this topic is because they could very easily twist this and ask you. They can give you 3-4 different points and ask you which is all part of the biosphere. And they can include nice twisty topics like maybe high temperature volcanoes or poles of the earth or something, and you can be confused over here. So understand, extreme points of the earth or extremes of both the north and south poles, or any extreme points of the earth where your temperature conditions, where any of your salinity conditions, your pressure conditions, all of these things, it is not actually aiding life or the creation of organic matter. It will be termed as not biosphere, because biosphere needs either of these components. If that is not there, it will not be in this case. So now, since we've understood biosphere also, let's come to something much more simpler. Okay, we have a term called as habitat. We constantly keep hearing it also. So my question is, what exactly is the simplest understanding of habitat? Is habitat home? Can you say home? Is habitat always home? No. Get it? Habitat can be called as basically the address of an organism. Address of an organism. So when you think of it like that, the address need not always be home. See, for example, we have home, we have office address, we have an address where we are going to some other place. If anyone takes maybe your Amazon, delivery addresses, you'll see all the different addresses which you've been in the past 5 to 10 years. So these are all the addresses that is there for a specific species, which means that habitat necessarily does not mean that is where the species originates or that is where the species is living continuously. Habitat can be just called as the physical environment in which an organism lives at that specific point. So right now, maybe the Siberian crane is in Russia and the address of the Siberian crane is Siberia, Russia. After a point, when Siberian crane is flying and coming to Koldio, the address of the Siberian crane is what? Koldio, Rajasthan. So at that point, that becomes the habitat of the Siberian crane. Got it? Which basically means what? You do not have a fixed concept. So for example, there is a bird which is there. The habitat of the bird would be a tree. Okay, now you cannot say that, okay, it can only be on this specific tree. If this tree is cut down, it will go on to another tree. So the idea of habitat, you can understand that is not a very rigid concept. It's not a rigid concept. It is something that can change according to where that species is occurring at a specific point of time. So it is the physical environment in which an organism lives, and it is the address of an organism. So let me ask you another term over here. Suppose, okay, there is an organism. Let's take a human for example. The human's current habitat is its home. Okay, this is the address. Now from the home, it's going to its office. Okay, so the human has reached the office. From the office, it again at the evening, it comes back to its home. Which means it's not that it's changing its habitat here and there. What is basically what you call it? The entire movement of an organism in a specific amount of time, and where all that organism moves in this manner can be called as a home range. Now I took the example of office, but at the same time, if you take up a Siberian crane, and Siberian crane coming all the way to maybe Rajasthan and then going back and everything, which means the home range of the Siberian crane is so large. Like from Russia, it's coming all the way or flying all the way, coming to Rajasthan, breeding over there, going back over there, which means the entire home range of it is big. Got it? So that is what is termed as home range, where all the species has been or it keeps on moving, if in a very pattern-like manner. So keep that term also in mind. There is something called as habitat, which is the present address over there. Then you have something called as the home range, where all these organisms or the movement of these organisms is charted. Okay, now to add to this concept again, think of it, you will have many habitats which make up the environment. Okay, so think of any environment area that you are in. Okay, let's assume maybe I am standing in a garden space. Okay, it makes it easier to assume all the different habitats. If you look at it, you will have a bird whose habitat is maybe the tree over there. You will have the grasshopper whose habitat is the grass over there, which basically means that entire environment which is there around maybe a tree or something is composed of, so if this is the entire environment, it's composed of smaller habitats. So now you understood why I told you habitat is a much more narrower concept in comparison to an entire concept of maybe what you say environment or so. So here many habitats make up the environment. Okay, now to add on to the understanding of it, a single habitat may be common for more than one organisms which have similar requirements. Again, what does that mean? Let's assume, for example, here you have the grass. Grass is the habitat of who all? The grasshopper maybe. The grass and the surrounding area you will have earthworms. And maybe on the grass you will have some kind of flies also coming also. Which means what? The same habitat is being shared by 3 or 4 different species. And 3 or 4 different species all have different roles over there. But what is the idea? You cannot say, okay, this species will only have this particular habitat. Okay, or for example, now the grass is over there. The same, what you say, grasshopper can go and maybe make some other kind of longer shrubs or something as its, what you say, habitat. So the idea is, what you have to take away from all this discussion is that the concept of habitat is not fixed. the concept of habitat is quite, what you say, fluid in nature. The reason being that several organisms can share one specific habitat. One specific habitat need not always be the habitat of a single organism. That can also change, and based on the movement patterns of it also, the habitat can change. So keep this in mind. The things that you will need to eliminate certain points is habitat is not something that is a very fixed concept. Okay. Now, since you've understood what habitat is, let's try to place habitat versus environment in very clear terms. The reason why we are discussing all these topics in detail is because, as I told you earlier, you need to have a much more better clarity on what these actual terms mean, how much you can actually, when a question does come, you should be able to crack it down into the simplest of its manner. So now coming over here, understand the difference clearly between habitat and environment. Now, let's not look at the first statement first, the second one. A habitat always has life in it, whereas the environment does not necessarily have life in it. Meaning what? So for example, how did I even define habitat to you? I said it's the physical environment of an organism. I said it is an address of an organism, which means by default, there is a kind of organism over there. There is life possible over there. So without life, or without any kind of the presence of any kind of life, you cannot define habitat in the first place. So a habitat will always have life in it. But does the same thing apply for environment? No. Why? Because in the first thing is, if I told you, it's just like I have an environment around me, a table, a chair, anything inanimate can also have an environment around it. Why? Because environment just is all the different factors around a certain thing. It can be the biotic factors, abiotic factors, them interacting with each other. But the entire concept does not revolve around the fact that, okay, there should be an organism, then only you can define the environment around it. Around anything you can have a general environment, which basically means this is a key differentiator between what a habitat is and what the environment is. Then coming into something else, where, as I told you, if you have a general environment, you will have several small habitats in that. Right, you'll have several small habitats. Now, the idea is the environment governs the properties of a habitat, which basically means if this specific environment that I am saying is falling under the temperature category of maybe 25 degrees Celsius, the rainfall of maybe 50 centimeter, don't you think this is what are all the abiotic factors over there? Based on these abiotic factors only, you will have any kind of life over there. So if any plant is growing, if any animals are there, all of that will be based on these criteria which is there. Now, when you have these criteria over there, don't you think all the sub-habitats over here would have those similar features? Yes. They will have those similar features, and that is why this statement has been said, the environment governs the properties of a habitat. What is a general environment will have a clear impact on what each of those habitat will have in as a specific abiotic or biotic feature. Now, so if you've understood all these differences, coming to the first one which is there, you can say in very simplistic terms that all habitats are environments, but all environments are not habitats. Why? All habitats, they will have some life in it, but at the same time, what did I say? It will have a physical presence around it, which means all habitats by default have some kind of environment around it. Okay, but all environments are not habitats. All environments means what? You have, as I told you, for defining a habitat, you need life. All environments cannot be habitats. Why? Because all environments need not necessarily have life. I hope this much is clear. These are all the statements that some of them have been clearly picked from previous UPSC questions, so that you can clearly analyze that also here. But if you've not seen the previous year questions, understand these are all the statements that can be twisted in several forms and asked. Okay. Now coming on to what we call as the different levels of organization, and this is where you have to understand when it comes to all the different levels which are there. Just like you have, for example, you all are part of this class. Okay. Now you are an individual. Few of you sitting together will be a group which is there. The entire group will be part of a classroom which is there. Several classrooms like this will be making an entire institute. Now that institute will have several branches that will making into something that is like a brand name or something. So here also there are several levels of organization. There is an individual level, population, community, ecosystem, biome and biosphere. What exactly is each of these things? Let's just try exploring it in a little bit depth. First thing coming into individual. Individual is something that we all understand. Individual is that single organism which is there. So when a group of these single organisms come together, which they are similar in nature, when they all are together, that is where you call as population. I want you to remember these diagrams. Normally, I do not ask students to remember or mug up anything, but the diagrams that I have put in these slides is all for a particular reason. The reason being that even if you forget everything else, any definition surrounding it, if you at least remember the picture, you will have some kind of idea as to what statement to pick. So look at this over here. In the first case, this was an individual, one single fish. Now, several kinds of those in different modes, like some of them big, small, whatever it is, they all came together and they formed something called as a population. So ideally, a population is a group of individuals which are of the same species, which have a defined area out there and which is occurring at a very specific time. Okay, now let's try to understand this population concept a little bit. Why? Because see, if you've ever read any newspaper where they discuss about there is going to be a census on the water bird population. There's going to be a census on the tiger population. Right. What are they intending over there? The idea is the entire number of tigers would be counted. Okay. Now here I want to add something. When I'm saying tiger, when I'm saying, for example, let's say we are going to do a count on the population of cat. Okay. Now you all know tiger belongs to the family of big cats. Okay. So you have a lot of cats. So when I'm saying tiger belongs to the family of cats, okay, so understand this. If you have tiger's scientific name is Panthera tigris. If I had to mention or if I had to take account of the population of cats which are there, what would I be essentially counting in it? Okay, tiger is called as Panthera tigris. Lion is called as Panthera leo. Will I be counting the tiger, the lion, the panther and everything into this list? What do you think? Think about it. No, we will not be giving all of them into the list. Why? Because as I mentioned, a population is composed of the same species organisms which are there. Now, when I'm saying the same species, here you will see the Panthera name is just the genus name of these things. The species name is all different. Tigris for tiger, Leo for lion. These are all different things which are there. So, if I'm saying I'm going to take a population of the cat which are there, it just means if there are any feline cats which are there, I'll be taking a count of it. I will not be taking account of the tiger or the lion, because all of these belong to an entire family of cats. You take your tiger, you take your lion, panther, your even domestic cats which are there, they all belong to one big family of cats. But then, if I am taking a population of cats alone, it will be related to a very specific species of it. So, they will have to specify which cat's population am I going to take the count of. So, this is why you have separate tiger population census, separate lion population census, and so on. Got it? So just clarifying that, you constantly hear the term population. Now, one more thing is, it is the number of same species. Now, a group of individuals of the same species in a clearly defined area for a very specific time. Okay, this is what composes what you call as your population. So if population is clear, now look at the second set which is there. What is being put over there? You have fish, you've grass, you've some crab like thing, you have a sea anemone kind of a thing, all of jellyfish kind of a thing, all of them are together. There is some plant component also, which means what? That when you say is what you can call as the community. Now, before I go into the community, let me add two more points over here in relation to the population. We'll go into the community very soon. Now, one thing that I want to add when it comes to the population growth rate is, or population growth as it is, see, when you take the population, just population which is there, it is, as I said, the number of individuals, a group of individuals which occur at a one specific time. Now, another concept that you have to be aware of is the population growth. First, let's assume population growth. Population growth means you take two time periods, maybe 2022 and then you take 2014. So, there is something called as a T, first time and second time. What you try to understand is how much has the number increased from T1 to T2. So, earlier maybe the number of tigers were 20, now the number of tigers is 100. So, you assume that the population has grown. Okay. Now, what is population growth rate? The speed at which it has grown. So, now for example, between 20 to 100, if you look at it, 80 species or 80 animals got increased over a time span of 8 years. Okay. Now, on the other hand, assume maybe before that, if you had 8 years prior to this, 2006. And at that point, maybe the number of species was just, what you say, 5. Okay. Here, 15 species have, or 15 numbers have increased in a span of 8 years. Which means what over here right now? The growth rate is certainly better for this one. In a span of 8 years, 80 individuals have increased in this group. In the previous thing, in a span of 8 years, only 15 individuals have increased. Which means this one has a better growth rate, meaning the speed at which the species or the population is getting replenished. Okay, so remember all these terms: growth rate, growth, and the general idea of what population is. Now, if that is all clear, let's move into what I called as the community. See, when it comes to the community over here, you will see that over in most of the cases in this picture, you will itself see there is a plant which is present over there. In most of the cases, several populations come together to form something called as a community. So, you will have the population of fish, crab, jellyfish, plants, everything. So, you will have several populations coming together. And based on what is the dominant plant form in that kind of a community, you will have something called, or that entire community will be named on the dominant plant form. So for example, if grass is a dominant plant form in the community, it will be called as a grassland community. If you have trees or a lot of such kind of large things which are over there, it might be called as a forest community. Got it? So based on the dominant plant form, the community is generally named. It's generally named, so you can have animal community also, but then the point is generally based on the dominant plant form is where the communities are named. Now, based on these criteria, you have two major categories called as major communities and minor communities. Major communities, if you look at it, these are large sized and relatively independent. Basically meaning what? For example, major communities, they will occupy very large areas, first thing. Second thing, they will have plant, they will have animals associated with it, and they will more or less be self-sustaining. Like for example, you take a tropical evergreen forest. A tropical evergreen forest, if you look at it, you have everything over there. You have rain coming in, the rain replenishes the soil, the plant grows from it, the plant is eaten by animals, the animal dies, again you have all these other conditions which enables it to be decomposed quickly, which means it's a very cyclic thing, it's a very self-sustaining community. Okay, so by virtue of having different species and having a very large area, that community has become self-sustaining. Good job. Okay. Now coming into the other thing called as minor communities. Minor communities primarily means that, for example, if you take any kind of a cow dung or something, there's a cow dung pad, and on the cow dung pad, like this is, if this is the cow dung pad, you will have small algae growing around it. To eat the algae, you might have some kind of small fly-like creatures coming in, which means what? That itself, you have different populations over there. So it satisfies our basic condition, which is that you will have different populations. Okay, it satisfies that basic conditions that you will have different populations of, there is organic matter, there is lichens. Lichens are basically those kind of organisms which are seen as, for example, I would say it's a combination of an algae and fungi. Okay, the combination of algae and fungi will primarily make these lichens, and these lichens, as you can see over there, you will see that they are having a good community. You have lichens, you have organic matter, you have the fly that is coming to eat the lichens, but do you think they are self-sustaining? No, it is not. Why? Because they can give nutrition, or they can have minimal resources just to sustain at that point. So here, minor communities are those which are dependent on neighboring communities and are often called as small societies. So if there is a cow dung pad, it is either a minor community or it is called as a society. They are secondary aggregations within a major community, which means, for example, if you take a tropical evergreen forest, which is a major community, you will have small minor communities all around that major community. Got it? This is why it is a secondary aggregation within a major community. So I hope that point is clear. So now, since we've gone to all these terms, we've checked out what is an individual, we've checked out what is population and what is community, thus bringing us into ecosystem. Can you all notice any difference between the picture that is the community and then the thing that is an ecosystem? What have you observed? Now, what I am basically observing over there is the fact that earlier you had the different organisms alone. When you define ecosystem, They have mentioned water over here. See, until then also we knew they all were living in water, but then the water was not part of the definition of what community is. Okay. Ecosystem, when I'm saying suddenly a rock has come, nearby to the rock, the crab is living very near to the rock over there. Then you have the water surrounding it. You have a little bit part which is the air over here. What has happened? Why is ecosystem being represented in such a very beautiful, detailed manner? And the reason for that is primarily because of what an ecosystem is. Okay. An ecosystem, and understand this in the simplest of terms because this is where a lot of questions do come from. An ecosystem is basically a community of organisms. Okay. So the community was already there. That same community's picture is what is being shown. But adding with the community, what all came in? You had rock, you had water and everything. Which means what? A community of organisms interacting with each other and with their environment such that there is some energy which is exchanged is called as a ecosystem. So if you are seeing a large rock, a fish nearby it, water surrounding it, generally a lot of fish and some kind of a grass and everything, what you're basically seeing at this point is you are seeing a lot of community of organisms interacting with each other, and they're also using these measures. The rock is being used by this organism as a house. The rock is giving out nutrients which is making the soil very fertile, which is helping the plant to grow. Which means what? It is actually interacting with each other and with their environment such that energy is exchanged. Okay, now when you have this entire structure, this is what is called as an ecosystem. Now my question is, don't you think this, by then when you look at it, it's going to be very similar to maybe what we studied as an environment? Because in environment also, what did I tell you? You have something which is having a lot of abiotic and biotic factors interacting with each other. This is what I said as environment. So then where is the difference coming in? What differentiates a ecosystem from an environment? Now let's try to understand that. So to understand the difference between ecosystem and environment, now you also need to understand one very key important factor over here. I told you they are interacting with each other. Now the factor is, when you take any environment, I am here. At this point there is an environment here. But is there an ecosystem over here? Think about it. In an environment, you will have biotic, abiotic factors interacting with each other. So till then it is all sorted. When it comes to an ecosystem, what is basically happening is, it is a functional unit of nature. Meaning at this point, if this has to be an ecosystem, there should be more number of species is the first thing. Okay, there should be more number of, it should be actually a community of different organisms. They should be interacting, there should be some energy flow, there should be some energy exchange constantly happening, and all these activities over here should be leading into something productive. Okay, which primarily means it is defined as a functional unit of nature where living organisms interact among themselves and also with the surrounding physical environment to actually create all these things: energy exchange and system level processes. Okay, which means if an environment is there, it will only become an ecosystem, or you can call it an ecosystem only when these different factors which are there. For example, if you take, this is an environment, there is some biotic things over there, there is an abiotic thing over there. At this point, they are interacting with each other also. This much is an environment. But now they are interacting to the point where they are creating some, or this entire interaction is actually performing a function, and that function is actually giving some kind of an energy exchange. Then only it will be termed as an ecosystem. Okay, this is why an ecosystem is also called as a functional unit of nature. It's called as a functional unit of nature primarily because it does some kind of activity over there, some kind of function is being performed over there. So if you look at it, any of these definitions would fit the bill. But let me just ask you, if they give you a very broad definition like saying ecosystem is a community of organisms interacting with each other. Does that make any sense? No. Because ecosystem is a community of organisms, that is correct. But them just interacting with each other will not create an ecosystem. They have to interact with each other to form something productive, to create something, or it has to have some relevance. They have to perform some function. Their interactions just like that, if they're doing, it will not be termed as any of these things. It cannot be even termed the community of organisms interacting with each other, cannot be termed as an environment thing also, cannot be termed as an ecosystem thing also. It's just a community of organisms interacting with each other. But you have a community of organisms interacting with the general things over there, the biotic, abiotic, all these factors, creating something productive or performing a particular function, then it is called as an ecosystem. So if you look at it, ecosystems can be man-made or natural. Natural ecosystems, we know a lot of terms. For example, the forest ecosystem, the taiga ecosystem, so on. Man-made ecosystems, what are the examples? How many of you know? Do you know any examples related to man-made ecosystems? You have something called as your croplands, etc. That would be under the man-made ecosystem. Then coming into a different categorization, which is your terrestrial and aquatic ecosystems. Terrestrial and aquatic again means that terrestrial would be those ecosystems which occur on land and aquatic is the one which occurs on water. Now, if this is all the case, let me ask you, in an ecosystem, do you have, or what is a sense of all the different species which are there? See, in an ecosystem, ideally, it can even perform with very limited species. It does not have to have like different kinds of, maybe 100 kinds of different species. Then only you can call it an ecosystem. Even when you have a very limited area, in those, if you are having even limited species, if they are doing this thing of performing or having a function, then also it is an ecosystem. This is the reason why, if I'm asking you, is tree an ecosystem? A single tree which is there, is that an ecosystem? Yes, it is an ecosystem, because of the reason being that in a particular single tree out there, you have different species, you have the different interactions, you have the nutrients around it. Because of all these reasons, you can call it a, what you say, in very clear-cut terms, you can call it a, what you say, a ecosystem. So now understand all these concepts. Why? Because these are all what keeps getting, tricky. And if you look at the previous year questions, the static part, ecosystem has been several times mumbled and jumbled and given to aspirants. Now I have put this picture over here. The reason being that, okay, when I don't want you to study the different zones or anything, but understand, when you have generally right now, a lot of questions do come from very weird species names that we have not learned. So anytime you get a species name, either you should be smart enough to, maybe for example, if you have a broad-necked warbler, if that is a term that has been given, you will have to figure out that, okay, it is a species which will have a neck, which means it will not be a snake or it will not be a fly or something. Got it? So these things you can use to eliminate things, but other than that also, it makes sense to know the terms or commonly repeated some terms which are there. So for example, look at it. This is basically an ecosystem which occurs in your lake which is there. So there is a littoral zone over here where you have the land and all these areas, a limnetic zone which is there in the water, a benthic zone which is at the underground of the lake, and here you see all these things. You see mosquito larvae, dragonfly, painted turtle, bluegill, bloodworm. Can you see the bloodworm is basically occurring in the benthic zone, which is underneath the ocean area. I mean, not the ocean, the lake area which is there. The bloodworm is not on any of the water areas which are there. So this is bloodworm. Musk rat, mallard, small mouth bass which is there, plankton, pond snail, bullfrog, diving beetle and water scorpion. These are all you can see. So now you know when you look at the origin of it. So for example, take water scorpion, you know it is there in the water areas, it is seen in lakes and everything. You can also figure out by, if they even give you a very confusing food chain which we'll be studying, you can figure it out from these terms also. So this is why those terms were just given to you. Now let's just move into few other areas. See, I was telling you till now ecosystem. Okay, now when it comes to an ecosystem over here, what we are doing at this point, what can it be termed? This is basically the study of interactions between organisms and the surroundings occurring within an ecosystem or environment. Okay, primarily meaning that when you have to study about any of the ecosystems, this is basically called as ecology. What did they do over there? They have just expanded what happens in an ecosystem. Study of the interactions between organisms and their surroundings occurring within an ecosystem or environment. So basically saying that in any kind of situation, you will have a lot of interactions between your organism and the abiotic components. When you have to study about all of these things, that is what is called as ecology. Now, just since we have reached to that point over there, I want you to be aware of some of the current affairs that have been in news related to this. So this is what we're going to do right now. Again, we all know about the IUCN, right? IUCN has been the pioneer when it comes to analyzing what kind of species has to be given certain protection or not. Okay, so you have a lot of instances where what IUCN does is they will be cooperating with the several other national governments which are there, and they will be figuring out which of these species fall as endangered, vulnerable, critically endangered and so on. Based on what the IUCN categorization is, several countries give extra protection, put it into several species list and so on. Okay, so this is what a general trend is. Now the point over here being, when you have something as a specific species, let's say the tiger. The tiger which is endangered occurs in a certain area which is there. Now, by now you should understand, when the tiger is occurring in a certain area, it so happens that it is not if you want to preserve the tiger, you cannot be like, okay, fine, we'll go and check the tiger every time. We'll go and see if the tiger is falling sick, if the tiger is having meals at proper time. This is not what is being done, or what has to be done, because it's practically impossible. How will you ensure that the tiger has a proper habitat? How will you go and ensure that the tiger has eaten food all the time? If the tiger has to eat food all the time, it has to be available out there in its habitat which is there. So now, which means that if you want to preserve species, it makes more sense to preserve the entire ecosystem itself. Okay, so now in this newborn concept of ecosystem driven conservation, IUCN has now gone forward and said, just like we give out a red list for your species, we are going to give a red list for your ecosystems. Now, when I'm saying the red list for the ecosystems over there, you will see that it is basically done after monitoring and documenting the different ecosystems which are there. IUCN will categorize it for biodiversity risk assessment. Biodiversity risk assessment means that in a specific ecosystem, is it actually helping to preserve the biodiversity, Is the biodiversity getting damaged because of any features of the ecosystem? All these things are what is being checked in that biodiversity risk assessment. The main objective is, once you understand which ecosystem is quite tricky, which ecosystem is going to be a little bit more, in an endangered condition, you can take conservation measures by evaluating all these aspects. So here, what would happen is, this mission is planning to be done by 2025, and from then onwards, we would also have certain red list for ecosystems. So understand this. This has been in news last year and this year, because IUCN is doing extensive work in coming and categorizing these several ecosystems which are present in each and every country, with the cooperation of certain institutions which are there on a national basis. Now moving on to the final terms that you have to know. The ecosystem current affair I discussed because it went along with that ecosystem idea. Now coming into another term, that is biome. A biome is basically a large naturally occurring community of flora and fauna occupying a major habitat. So for example, biome basically just means, and as I was discussing earlier, a biome basically means it is a large habitat area. For example, if I'm saying tundra, okay, so you will have several groups like smaller ecosystems over there, but on a large scale, you can call it as a biome. Okay. Now, since these terms are all clear, we move on to the next section, which is your components of ecosystem. So, we have right now our pathways. We were discussing the different levels of organization. Okay. Now, coming into the different abiotic factors which are there. Now, in the case of an ecosystem, you will see certain abiotic components and you will see certain biotic components. Okay. So now let's see our pathway. We started off with what an ecosystem was. We went into some current affair related to it. We understood that the clear definitions of it, the difference between an ecosystem and environment we checked out. And now we've reached to the point where we're discussing which are the different components of the ecosystem. The different components of the ecosystem, the first thing is your abiotic components. And in the case of the abiotic components, they are the inorganic or the non-living parts which act as a major limiting factor. Now, there's a lot of terms over here, we have to understand this. So, you have certain inorganic components, and they are the non-living parts which are acting also. So, what exactly is this concept? So, when I'm saying what exactly is this concept, you have to understand, abiotic are when I said it's the inorganic and the non-living parts, then you have certain things like your energy, rainfall, temperature, atmosphere, substratum, latitude, altitude, all of these happen to become the different components of the ecosystem. Okay, so when you have these different kinds of components, you also understand that based on the change of any of these components, the ecosystem also suffers or has some kind of an impact. Now, let's try to understand amongst the different components of the ecosystem, why did I use the term limiting factor? Okay, let's try to understand this in very simple terms. You have an ecosystem out there. In an ecosystem, you have a lot of organisms which are there. Okay. Now, take one single organism which is there, maybe a plant. Okay. Now, in the case of the plant, don't read what is there first and try to understand this, and then we'll go into the topic. See, the idea is, so for example, if you take a plant, that plant is now in the soil which is there. It's getting some nutrients from there. It's getting the oxygen also. But what has happened is, ideal situation, it should have got the water, the air, the oxygen which is there, the nutrients and everything in the right amount, and it will grow in a very nice manner. Okay, but for some particular reason, there is a concept where maybe there is some kind of a nutrient which is very less in quantity, or there is no water which is there. Okay, which means out of all the 3 ideal conditions that the plant should have got, only 2 are satisfied. Okay, 1 not satisfied. So the concept over here of limiting factor is that one factor which the plant has not got in its right amount will become the limiting factor. What is a limiting factor? A limiting factor is something that holds someone back. Okay, a limiting factor is basically something that, for example, if you have a limiting factor, that will be the reason that you will not be able to pass a certain exam. Let's just put it in your terms that you can understand. You are an individual. Ideally, to pass UPSC exam, you need to have a good skill for marking your prelims answers. You need to be able to revise certain things in a good manner. So you have to do test, you have to revise, and you have to have some knowledge. Okay, now you have knowledge, you are taking a test also, but you've missed out one part, which is revision, because you're like, oh, I cannot, it's too boring to sit and read everything again and again. So what has happened is, you are doing the other 2 in abundance. You're taking so many tests, you're reading so many things, but then you're not revising, which becomes what? That revision component will become your limiting factor. That will be the reason why you are not able to perform well in the exam. Similarly, when it comes to the plant also, you will see that the environmental conditions that limit the growth, abundance, or distribution of an organism or population of an organism is in an ecosystem is called as limiting factor. So it need not always be the same thing. See, so for example, some plants will have your air or maybe your rainfall as a limiting factor. For something else, it would be some other component. So it can vary from individuals. And one very common limiting factor that a lot of plants do have, or a lot of organisms do have, is your nitrogen. When we study the nitrogen cycle, we'll study this in detail, but understand when it comes to nitrogen, a lot of plants suffer. Why? Because nitrogen is that thing which is, it's not there. You need nitrogen, but it's not available. So you have to give fertilizers and all that. In that case, the limiting factor will be compensated. But if you're not giving any fertilizer, what will happen? It will remain as a limiting factor and impede the growth of the plant. In this context is where there is a specific law called as Liebig's law of the minimum. Okay, Liebig's law of the minimum states that the growth is not controlled, or growth is controlled not by the total amount of resources available, but by the scarcest resource. Okay, which means this plant can get abundant amount of sunlight, abundant amount of nutrients in the form of fertilizers, but still if the scarcest resource is water, the growth of the plant will be determined by water. Okay, which means again, for example, in this case, this plant which is not having enough of nitrogen, it will have enough of water, enough of air, enough of sunlight. But despite all this, if nitrogen is not there, this nitrogen is what will determine the growth of that plant, which means the growth is controlled not by the total amount of resources available, but by the scarcest resource. Okay, so this is what Liebig's law of minimum said, and this is quite important when it comes to understanding certain things. There are a lot of questions which come derived from this concept. Now coming into certain biotic components. So what we'll do first is, we'll just look into all the biotic components which are there, and then we will just move into the abiotic one's detailed explanation. Okay, coming to the biotic components which are there, as you know, in any situation which is there, you have something called as the primary producers. These are the organisms which are otherwise called by the term autotrophs. and they are the ones which produce the food in an entire ecosystem. So you have green plants, you have microscopic algae, any of these things which are capable of producing their own food will fall under that category of primary producers. Then you have something called as your consumers. And in consumers, you have macro consumers and micro consumers. Okay, understand that macro and micro is based on the size and the capability of energy transfer. Okay, so if you look at that perspective, macro is basically your macro consumers are your heterotrophs. Micro consumers are something that we call as your detrivores. Detrivores are organisms that feed on dead organic matter. So you will see nematodes, these are all class. See, remember now UPSC is asking a lot of these scientific terms or organisms that we don't have any clear idea about. So remember, just when you hear these things, at least place it in your mind like, okay, these are smaller organisms which are feeding on dead matter. So if you look at it, nematodes are basically your hollow worm-like organisms. Arthropods are your insect-like organisms, and earthworms we already know. These are basically called as your detritus feeders. Okay, so in all these aspects, these are the ones that are basically what you say the different components of consumers which are there. Now coming into the different concepts of your abiotic factors. See, understand that when it comes to the abiotic factors, you will have the first major thing being your light. If you take any organism out there, it derives its energy, and basically your plants which are there derives its energy from sunlight. Now what I want to tell you is, when I'm saying light as it is, the light as it is composed of all of these things. You have radio waves, microwaves, infrared, visible light, ultraviolet light, X-rays, gamma rays, etc. Now if you look at it, look at the kind of wavelength which is there. You can see that here this is an increasing wavelength. So wavelength is basically gradually from a very high wavelength, it's moving into a very low wavelength. Okay, which means out of all this, just have a basic understanding. Your radio, micro and infrared has a high wavelength, and your UV, X-ray and gamma has a lower wavelength. Okay, just understand this. Just don't mug up any of these things. If you take wavelength, high is basically your infrared, low is basically your UV. Now this is in the terms of your wavelength. Now whatever I said in terms of wavelength, if I said frequency, it would be just the opposite. Which means in the case of frequency, your IR or infrared radiations will have low frequency and your UV radiations will have high frequency. Okay, so this is the concept when it comes to the different kinds of frequencies. Now, when I am saying light, ideally, technically, it's all of these things. But if you look at it in a very clear manner, this is pertaining to, or if I am saying a plant is receiving light, okay, you will have all of these components. But which is a major component that is equipping us to see, or the entire utility of light happening on the earth is because of which of these things? It's because of this category, which we call as visible light. based on the capability of humans, we are able to see only what we call as visible light. Now, in the visible light over here, as you can see, there is red, orange, yellow, green, all these things are there. So, from red to blue, if you look, red has a much higher wavelength in comparison to blue, which is having a much lower wavelength. Red is much more closer to the higher wavelength area, right? So, understand this much parts. Light, as we see, as humans see it, is visible light. In the visible light, you have a certain spectrum which has light colors from red to blue. Now, one basic information that you have to understand is, if I am seeing anything with a particular color, that is because that color is actually reflected back from that object. So, for example, if there is a leaf and I am seeing the leaf in green color, that's because the leaf has reflected green color back to me, and rest all the other colors which are there, red, blue, everything is being absorbed by the leaf. Okay, that is why apart from green, all the other colors get absorbed. Only color which is reflected is green, and that is why I am seeing the leaf as green. Now coming to my third point over there, if all the other colors are absorbed, it must be of some utility to this plant. The red, the yellow, the blue and everything should be of some utility to the plant. And this is where we come to all these points. Quite important in that aspect, I would say. When you look at it, if you take the entire solar radiation which is there, the solar radiation is in this spectrum. In the spectrum, if you look at certain factors, there is red light and there is blue light. First, let's understand the importance of red and blue light. First thing is, if you have, or for example, in the normal case, if a plant is there outdoors, okay, it's there out in the open, you don't have to bother about any of these things. Why? Because the plant is there out in the open, it's receiving spectrum in any situation that is there, it's all getting the light from the sun. It'll take red, blue, whatever it wants. These things come into picture when you're doing experiments specifically, and that is where you understand, if you want some plant to flower quickly, if you want it to fruit quickly, or if you want the fruit to ripen quickly, you just have to show it under red light. Continuous exposure to red light will aid the flowering of the plant and the fruit production. Thus meaning what? Red light, which is of a higher wavelength, has much more higher energy over there, and this is basically aiding the flowering over here. Okay. At the same time, if you look at the blue light, if you want your plant to grow very fast, and this applies to all those people who have these indoor plants and they are going on dying off and you do not know what to do with it. So at this point, if you want your plant to actually be very strong and durable and have a very good shoot growth, okay, shoot growth basically means that, so for example, if you are showing it continuously under blue light, the important thing is the chlorophyll production will increase. And as you know, the chlorophyll is basically the chief component that is required for photosynthesis. Okay, the chief component that is required for photosynthesis, the chlorophyll will be actually produced in good amounts. It will be strong, durable, healthy stem and leaves which are there. So when you have this kind of a growth, it makes sense. Why? Because these things will be, when you look at it itself, the plant will be growing like in a very, it will be like an Usain Bolt. It will be like very fast, very strong shoots. So both red light and blue light has its good points. But now coming to the next part of it. The next part is it, if you continuously expose it just to red light, what is going to happen is, this extremely high intensity, which is this one, the flowering of plants and all, that will happen. But on the other hand, the shoot of the plant will not grow. Which means on continuous exposure to your red light, On continuous exposure to your red light, you will see whatever plant has grown, it will flower and everything, but beyond a point, the shoot will not grow. Why? Because you're exposing it only to red light. Ideally, it needs red and blue, then it will grow in a nice manner. But here, you're only giving red light, which means that extremely high intensity favors root growth than the shoot growth. Which basically means that if you are continuously exposing a plant to red light, the impact is the root will grow in a very nice manner. The shoot will suffer. And when I'm saying the shoot will suffer, basically what will happen is to keep life going, the shoot, whatever is there, it will have to work over time. It will have to keep working. This will lead to increased transpiration. Transpiration is basically the loss of any of these vapor content from the plant which is there. So it will lead to increased transpiration, short stem, smaller, thicker leaves. Okay, the plant will be very stunted if you are exposing it continuously only to red light. Okay. At the same time, if you are exposing it only into blue light, what is going to happen is, again, the shoot will grow in a very beautiful manner. The root will suffer. Basically meaning that if you are just showing it under blue light, the root will be very underdeveloped. The root will not have the capability to pull water and everything, which primarily would affect the flowering of the plant. Now, the reason why it is actually happening is when you continuously expose something to blue light, okay, you are, if you look at it, the plant's chloroplast is there, and the plant's chloroplast will take up all these light, and it has a method of taking energy from all this, and it will break it down. Now, when you're continuously exposing something into blue light, there is a growth hormone called as auxin. The auxin is what aids the growth of the root. Okay. What happens when you're continuously exposing something into blue light is because, see, ideally when it is out there, if you have red, the red light actually aids the production of auxin. And this is what leads to the growth of the root. But when you don't have that high intensity light, but then you're just giving only blue light onto it, what is going to happen is the auxin is not produced. If the auxin is not produced, what is going to happen? The root will suffer. The root will not grow properly. And this is what has happened over here. Okay. Similarly, when you are just showing the root, the red light over there, the reason I told you when you show the red light, the root will grow, but the shoot will not grow is because when you show red light, the auxin is there. But you need certain other growth hormones for the shoot to grow, and that is not produced. So understand this, a very good tricky question can be asked on both of these terms. So understand that you need red light and blue light in proper amounts. If either one of it is exposed to too much, what is going to happen is these impact is going to there. They could very easily ask you a simple match the following question, because this is all something that is being mentioned in the NCERTs. Now you don't have time to sit and read the NCERTs at this point. That is why this is all being compressed and given to you. Okay. Now when it comes to the temperature part which is there, so we dealt with light. Now coming into the temperature, you have to understand that, see, when you have any plant which is there, okay, so the plant cell has proteins in it. Okay, and what happens is, proteins are those kind of substances which can easily change its nature when subjected to temperature changes. Which means at times when the temperature is high or when the temperature is extremely low, the protein's shape keeps on changing. Okay, so protein gets denatured based on the temperature which is there. Now, ideally, in all of our bodies also protein is there. In the plants also protein is there. But in the case of the plants, they are much more severely exposed to your different kinds of temperature changes which are there. Right, because they don't have a clear, regulation mechanism or anything, which means that when there is a temperature change, ideally what would happen, or in most cases what would happen is, the different proteins which form part of the plant cell, they will get coagulated. Coagulated basically means it will get into a very solidified mode. It will get solidified. Basically, what happens if it gets solidified? See, for example, what does the plant cell do? If you have cells continuously stacked, the plant cell is what takes the different water, nutrients and everything, and it keeps on transferring it from one cell. It keeps on transferring it from one cell to the other, and this is what is being used by the plant for its certain functions. Right. So now what has happened over here is, when you have the proteins and these proteins are getting coagulated, basically means solidified, the transfer from one cell to another will not happen. Why? Because you have a very strong solid barrier over there. Each protein which is there, it has water over here or any nutrients over here. To transfer from this one to this one, it has to cross through this protein layer which is there. What happens if the protein layer is solidified? If the protein layer is solidified, you cannot transfer it in a very easy manner. So now what has happened is, if it cannot be transferred in an easy manner, the plant will start dying off. And so here you will see that when temperature changes happen, here the plant starts drying off, the desiccation of the plant tissues happen, and the plant is actually devoid of any moisture. So here, to observe it, if you look at it, ideally this is the condition which would be there. You will have a plant whereby which the plant slowly starts drying off, and the drying of that plant will be in this manner where the tip of the plant is first affected and then it gets transferred to all the rest of the plant. So from the tip to the shoot end, the plant will slowly start drying off. Why is this happening? Again, the reason being that if you take any plant stem, you will have cells stacked in this manner. If one thing is not able to get water, it will not be able to pass on to this, which means this will die. If this is dying, this is in relation to this. This is also not getting any water. This will die. This means from the tip to the backwards, this thing will die, and that is called as dieback. Which means when it is exposed to temperature conditions, plant will die off. And this is called as dieback. So now we've covered two aspects, which is basically your temperature and the idea of what light will do as part of the ecosystem. In the next session, we will be covering what frost and snow and the rest of the ecosystem parts in the next session. Until then, just keep revising this. If possible, read the NIOS material and do the task that I gave to you also. Thank you, guys.